So go ahead and prove that the function is continuous or discontinuous at 2 and 3. So let's start with an x value of 2. So therefore we need to use these two functions. So what is f of 2? To find f of 2, we need to use the second function because x is greater than or equal to 2. So that's going to be 2 squared minus 2, which is 4 minus 2, so that's equal to 2. So f of a is defined. That's step 1. Step 2, we need to show that the limit exists. So first, we need to find the value of the limit as x approaches 2 from the left side of f of x. So on the left side of 2, that's when x is less than 2. So we got to use this function. And so that's going to be the square root of 2 plus 2, which is the square root of 4, and that's equal to 2. So now we got to check the right side. The limit as x approaches 2 from the right. On the right side, x is greater than 2, so we're going to use this function, x squared minus 2. So that's 2 squared minus 2, which we know is 2. Now, because the left side and the right side are the same, that means that the limit indeed exists. So we could say that the limit as x approaches 2 from either side of f of x is equal to 2. Now notice that these two are the same. So now we can make the statement for step 3 that the limit as x approaches a, or 2, of f of x is indeed equal to f of 2 because they both equal 2. So therefore, the function is continuous at x equals 2. Now let's move on to the next example. And that is at an x value of 3. So we need to use these two functions. So first, let's determine if it's defined at 3. So f of 3, x is equal to 3 in the third part of the function. So it's going to be 2 times 3 plus 5. 2 times 3 is 6, 6 plus 5 is 11. Now let's move on to step 2. Let's find the limit as x approaches 3 from the left side. So therefore, we need to use this function. 3 from the left is going to be less than 3. So it's 3 squared minus 2. 3 squared is 9. 9 minus 2 is 7. Now let's find as x approaches 3 from the right. So we have to use this expression. So it's going to be 2 times 3 plus 5, which is 6 plus 5, that's 11. Now notice that the left side and the right side of the limit doesn't match. So therefore, the limit as x approaches 3 of f of x does not exist. And if the limit does not exist, it is not continuous at x equals 3. So therefore, you could say it is discontinuous at x equals 3. Now, because these 2 points do not match, and we don't have a rational function, this type of discontinuity is known as a jump discontinuity. Now let's work on some more examples.